Thank you so much, Fran, and thank you, Zan, as well as Des, for having me. And of course, to everybody here on this webinar, thank you again from the bottom of my heart for joining us. So today we'll be talking about the DESS Dental Smart Solutions, which is a third-party implant component solution. And it really provides a very robust level of value for the laboratory, and that's what we'll be discussing today. And certainly, as Fran said, feel free to ask any questions to make it more valuable for you, because what my hope and my goal is in all of this is to provide value so that you can absolutely see and recognize it in your business, in your laboratory, and it allows you to elevate your revenue stream or your time or whatever have you. So what is the DESS implant solution difference? If DESS has been around for quite a while, and many have used it, but some nonetheless may not. But it is a family-owned and operated business with a long history out of Spain. They've been doing this for a very, very long time. It is FDA as well as CE and Health Canada approved. They have very unique opportunities, such as the pure switch concept at the core, which allows for over 31 different connections of all the major implant components. So it offers the versatility for the laboratory to really be able to engage in a meaningful way. And I'll give you some examples of how it can immediately add a revenue stream and an enhanced bottom line to your laboratory, allowing you to not only create greater revenue for your laboratory, but also grow your implant prosthetic department. So it is a global company. So it's not a fly-by-night type of company that is here today and is going to be gone tomorrow. They're currently present in over 40 different markets. So it's a global entity, it's a global corporation and a global company that really aligns incredibly well with Zan. And that's a benefit to the dental laboratory community, and certainly for any customers of Zan. And I'll discuss that at the end, because it gives the robust strength of two global giants in this space in Fortune 500. So it has many unique and patents and solutions. So not only does it have all the 31 different major components for all the major systems, that is, it offers some unique opportunity with patent solutions to really optimize your offering, and what we're going to discuss in a little bit. So it's not just a third-party component, which is what I absolutely love about this company, DESS, because they've taken a look at it from the lens of a dental laboratory, for lack of better terms. They've looked at it to see how can we improve the prosthetic end, or the implant supported prosthetic, for the laboratories. And they've really created a very robust portfolio of solutions that really affect the laboratory very positively in a tremendous way, which we'll get into. But as far as the price ratio, currently it's a performance ratio of a saving of 30 to 50%. So just keep that in the back of your mind, because there's opportunities within the DESS solution that you can really enter that. And one of them, for example, is oftentimes we're in the laboratory, we get a case and we get a certain implant manufacturer. So that typically necessitates the need for the dental laboratory to make a phone call to that manufacturer in order to understand what it is that the components are going to cost prior to giving the doctor a quote for the prosthetic. So oftentimes the doctor calls, has Mrs. Jones in the chair, and wants to give them, Mrs. Jones, a price for what the protocol or the treatment plan will be. So they call the laboratory to get a quote or a price, and that again necessitates a call for the manufacturer. What's nice with the DESS implant solution is that all the third party for the major implant solutions are all the same price. So what does that do for the laboratory? Take my example as I shared earlier. When a doctor calls and Mrs. Jones is in the chair, all you have to do is know how many implants there are, and now you can formulate what your quote is. It's a 30-second conversation with the doctor, and then the doctor can turn around and tell Mrs. Jones what her cost would be, because now he understands what the prosthetic aspect of the costs would be. So that's where a true benefit to the laboratory, where it's irrelevant as to which implant material or implant system it is. all the tie bases are of the same price. So it doesn't fluctuate with anything. It's all through Zon, and you're able to buy the components directly through, which give you a ratio of 30 to 50% off of all the popular brands, which is absolutely remarkable. Imagine that's a 50% profit, if you will, for the laboratory right off the bat. Now, I have to say this in the very beginning, this is a third-party component manufacturer. So, ultimately the dentist is the one that's responsible for the patient and the patient's care. We have to always 100% be completely transparent. And what with this is, it's just a opportunity to be able to show the dentist that there are other options, and ultimately they'll make that decision. But you're arming that dentist with information that I'll be sharing with you throughout this hour, so that they feel the confidence and allow the dental laboratory to restore with these prosthetics, if you will, so that they have the confidence, because ultimately they're responsible for the patient, and we as a laboratory community must be fully transparent all the way through. So this is a third-party system, a solution for implant components. They're not OEM, and if a dentist requires an OEM kind of component, then obviously as a dental laboratory we must comply, because that's ultimately who's responsible for that patient. But there are other options, just like we have as consumers in the regular world and not in the dental world. There's always options with multiple manufacturers, and even some that are perhaps a better or worse. But this is just another opportunity to be able to educate your dentist, to tell them what these components are, which I'll be sharing with you in the next few minutes, and how that then translates to the benefit for the patient, which is what is ultimately what we're all here for. So within the DESS Smart Systems, depending on it's irrelevant, or it doesn't depend on the type of workflow that the dentist uses, or nor does the laboratory. So if you have a dentist that is still not digital and is conventional, and they like to take PVS impressions, you can still certainly accept it. Pour the model, whether it's a closed or open tray, same as what you're accustomed to. You can pour the model, and if the laboratory is not digital, then you can wax it and then form it into a digital and zirconian delivery. Then there's the digital kind of approach to the standard of care, which is the intraoral scanning. Then you have the full CAD design in both 3Shape and ExoCAD, which I'll get into in a little bit. And then you can go ahead and mill the zirconia and delivery. Obviously, you can see from this this display that it's a shortened cycle and a shortened amount of need to work. Now, you may have which I would venture to say that most laboratories and most clinicians are probably in this space where they're 50-50. They're not fully analog, they're not fully digital, they're somewhere in the middle. And again, the DESS Smart Components has the ability of interjecting in multiple ways. And I'll show you what I'm referring to, because they have parts in both the analog and the digital and everything in between. It's a full solution for the laboratory to be able to get to the end result, which is the implant supported prosthetic. And whether you're conventional, whether your dentist is conventional, whether the laboratory is conventional, or vice versa, or some form of hybrid, you're still able to utilize these components in a great way. And it's truly a robust system that allows any kind of solution that is presented in the laboratory. Now, one of the things that I also very much like about their system is that they have lab analogs, or that are identical to what the OEM components are. So meaning that the same color structure, they're durable, they're made out of the same stainless steel titanium. They're color coordinated exactly as it is in the OEM components. They're absolutely guaranteed, because it will fit, because it's up to geometries, and I'll make a better case of that down into the presentation. It also has a self-lock-in or stability in stone. And now although it says coming soon, they do have a availability for new 3D printed model analogs. So what does that offer you and off the bat? So if you do have that pushback from your clinician where they only want an OEM part, lab analogs is your first point of where you can generate a greater revenue for your laboratory, meaning that lab analogs, as you see here, never enter the oral environment in the patient. Those are typically discarded, but we need it in order to verify the passivity and verify it on the model and so on and so forth. So that's a product that oftentimes, if you're doing an all on X, whether it's 4 or 6, if it could be a savings of approximately, depending on the manufacturer, of $30 to $40 per each lab analog, you can do the math. If it's an Olon 6, then obviously you can do the math times 30 or 40, and that translates to anywhere from $200 to $300 revenue, direct revenue to the laboratory. And again, it doesn't subject the patient in any way. It never leaves, the laboratory oftentimes, and certainly not in the oral environment. So this is where there's a nice opportunity right off the bat with these cases to generate an increased profitability, because it's not, I want to say revenue, but it's profit, because the costs are offset because it is 50% lesser than what some of the OEM parts. And that's something that you can capture as profit for your laboratory right away. So a lot of laboratories are engaging in this, certainly with lab models. Now, they offer different opportunities, and I'm just sharing what some laboratories are doing. They're offering a intraoral tie-grade 5 laser-marked intraoral scan flags. Now, scan flags are very important for the complete process of designing a implant-supported prosthetic, because the scan flags is what gives us the placement, orientation, and the timing of the implant. And that's really important to make sure that you have the right scan flags and the right capture, because that will absolutely affect the passive fit. So oftentimes you want to make sure that you have the right scan flag, especially with digital. And DESS offers this, which again is versatile and open to all different large manufacturers that are available now. And some laboratories are even ordering these in order to resell to their clinicians at a profit or a cost, or whatever the case may be. That's more of a business model kind of decision, but the opportunity is there to streamline everything all the way through. So now the dentist doesn't have multiple systems of scan flags in order to extrapolate. You have one system, one intraoral, and it's all tie grade 5. They also have, my apologies. They also have a desktop peak laser mark, which is, again, for our desktop in the laboratory. And this is one process here, the tie base or the Oron base peak, which I think is a very novel thought as to what it is. Now, I've certainly received these type of cases, and I'm sure you have as well, where dentists want to skip over the scan flag. So what they do is they scan, or they take an impression of the tie base. And what do we used to do in the laboratory? We used to kind of plot the most peripheral end of these tie bases as a crown and bridge case. And we all know, hopefully, those that have done it, that the fits are absolutely not very good, because it was never designed or never really made for that. So again, the emphasis of the scan flags are really important for the location, the angulation, and the timing of this. So now you have a solution if you are faced with a case similar to this, where you have this, you can either purchase it in peak, or you can even get it as an STL file that you can 3D print locally in your laboratory. So it offers you the ability of salvaging a case that perhaps would have been a challenging one, to be able to really bring it back and make sure that it seats properly, that everything is seating passively and engages in the right way. So this is a solution, again, that the DESS Dental Smart solution really came up that I absolutely love. And it's that cap that you can either buy from Peak, or you can actually get an STL file in order to manufacture it yourself. Now, the DESS it has libraries that are integrated in all the common intraoral and desktop scanners, obviously 3Shape, exocad, as well as Dental Wings and some others. But there's a way of actually incorporating those libraries, which I'll share with you in a little bit. Now, as I said, they have proprietary benefits. So the company looked at this and said, okay, the geometry is one thing. We can manufacture this, and we can certainly have the robust way of manufacturing, but what can we add to the laboratory community in value? And this is a perfect example of what they've added, which is the retention surface, which they call the Select Grip. Now, it is a patented solution, but what it's provided is the 5 times improvement of retention compared to machine surfaces. Now, that's just one aspect, which is a huge aspect, because if it's 5 times stronger in retention as far as the bondability, it right away improves the viability and your longevity of your prosthetics. But it also creates a labor benefit in a great way, because the factory applied, it requires no need for any kind of critical surfaces. So, typically what a laboratory does with the normal tie bases prior to bonding it, they would go and air abrade it with sandblasting, and obviously certain areas are not to be air abraded, and that's challenging sometimes because it's very, you have to protect it either with wax or whatever have you. So you still require a technician to be able to do that and then go and air abrade it. This actually saves processing time because that function is no longer needed. And not only that function no longer needed, that you're not affecting any of the surfaces that should be untouched, but you're not necessitating air abrasion, but it also creates the coating creates a 5 times improvement in retention. So you have a tremendous benefit, not only in the value of your prosthetic, but also in saving of the processing time within the laboratory. And as we all know, time equals money. So that, again, allows the laboratory to generate or increase their profitability from every one of these cases. So there is an appreciated added value without a truly extra cost in any way. Now, when it comes to angle and design, they've come up with, again, certainly we were able to angulate or correct the access hole. And I'll talk more about how to properly angulate the access hole. But, you're able to angulate it 360 degrees all the way through, up to 25 degrees. But what they've done is they've actually shortened the shaft and created a parallel walled cylinder to increase the strength and retention. But the short staff also increases the translucency, so you don't get the unsightly of the grayness, which sometimes we see with implant prosthetics. And they've even taken it a step further, where they've created it with a gold hue to create a warmer gingival tone. So not only is the shaft shorter, it has the retention, which is significantly stronger. It has the gold hue, so you no longer have to be concerned with that grayness showing through, because that gold hue is going to give the gingival tone all the way through. Now, just as a preface, and we'll talk a little bit about biomechanics, but you want to be careful with how much you angulate. And certainly on 3Shape and others, you can angulate 20 degrees, but this allows you to angulate even further. The one word of caution is, depending on how long the axis, the screw chimney is, you want to be mindful that you have to be able to, the laboratory has to be able to engage with the screw in order to tighten it, and certainly the dentist has to. So sometimes you want to be mindful not to over-angulate it, where if it's very long chimney, you're not going to be able to gain access to the actual screw in order to torque it down in the patient. And this is where this allows the broadening of the platform, allows that angulation to be even easier and more meaningful, so that you're not stuck where it's like you've angulated in the right place, where you're no longer are concerned with the aesthetic ramifications and the biomechanical ramifications, but now you're having a challenge with accessing or engaging with the screw. That makes that prosthetic not a viable prosthetic, and certainly if the dentist can't attain it. So just be mindful of that, and we'll talk more about biomechanics, but be mindful with how much you're angulating and where you're angulating, so that it doesn't compromise the viability of the prosthetic.
And is it okay to launch our first question?
Oh.
Because it is on angulated screw channels. Is that okay with you?
Absolutely.
Okay. Are you using angulated screw channels? If you wouldn't mind answering. This will take maybe about 30 seconds. And so far we're at 50-50, Dan. So it seems like 50% of our audience is using. Nope. More people are. Wow. Awesome.
Excellent.
So it seems like 60% of our listeners are using angulated screw channels, and 33% are not.
Excellent. Well, it's good to know. So I mean, certainly, hopefully, the larger percentage that is using it, hopefully they're mindful of that, the length of the chimney hole, so not to get into that precarious position where now you can't engage the access hole. And certainly the ones that are learning about angulating screw channels is just be mindful that beyond a certain amount, you just want to be mindful that the screwdriver can actually engage into engage with the screw so that you're able to torque it down properly. And this is where the RM base and the angel base really comes in, because certainly we know that the zirconia is strong and self-supporting. So we're not concerned with the strength of the material. And certainly once it's cemented with 5 times the strength, it's a complex that is acting as one. So, but what the benefit of with the RM base that DESS provides is that they also offer a higher shaft that will block away any kind of translucency. And remember, it's in the gold color and allows you a 360-degree freedom, which you can see here from these displays of the shortened shaft on the lingual allows a greater angulation achievement in these type of implant supported and certainly screw access holes. So things to be mindful of, and I have an example of this following, but where these really come out where they're very, very helpful. I mean, certainly we've all been in this situation where we get a case and the implant is placed out in left field for whatever reason or whatever have you. And oftentimes I've made the phone calls to the dentist or the surgeon, and I'm sure you all have as well. And what's the typical answer that we get? Oh, that's where the bone was. Well, I understand that's where the bone was, but there's other places where the bone is, but nonetheless, the implant is already set, and we have to come up with solutions of how to, A, make it aesthetic and not compromise the aesthetics, but also, most importantly, is the biomechanics of it. And I'll get into that in a little bit, like where it is that you want to place that access hole, that it's not going to compromise the longevity and viability of your prosthetic, which sometimes, believe it or not, some laboratories do that unknowingly. And that's what we'll discuss in a little bit. But this is a product, a component that really makes that easier, or that element easier, that if you do have a case that's completely out in left field and you still want to have a screw retained restoration, you can have these with a 25-degree angulation without even engaging into multi-units, which we'll talk about in a second. Now, the multi, oh, my apologies. So here's a case, and it's, again, a single restoration case where you see where the implant is placed, and it looks like it's placed in the right location. And only when we go to the next, oh, sorry. Only when we go, so once we see this, the implant, and we start designing it, and all of a sudden we're seeing that it's coming out in a very aesthetically compromised place. So we can angle this up to 20 degrees without being concerned, and making sure that, for as far as biomechanics is concerned, you want to have it the forces distributing along the long axis of where the implant is. So if you're looking at it this way, obviously the forces are going to be coming onto the lingual cusp, and it could potentially create a catastrophic result. So you want to angulate it where it's going to support biomechanically where the forces are distributed to. And certainly you want to create it where it's not in a functioning area, nor is it at the very intersection of that. So you can angle it to a non-working aspect of it, depending if it's the maxillary or the mandible, and the location of it, so it's not going to be in a functioning area. But you also want to create the long axis so it could transfer that those mastication forces in a great way. And here you have this is the definitive or the finished restoration. You can see the access hole now is closer to the fossa. It's not in where it would have emerged out of the buccal cusp. But if you're looking at this, if this is where, if we were not to correct the angulation, it would come right through here and create this whole lingual aspect exposed to the biomechanics. And again, the biomechanics is any structure is as strong as it could be, depending on its weakest link. So we have to look at where the weak links are and how do we correct those weak links so that the whole system or the whole structure becomes stronger and more viable. And this is an elegant way of correcting that, because it's in a non-working, again, function, and it also distributes the mastication forces properly along into the implant rather than creating a potential failure in the process. So angulating it, and we'll get a little bit more into the biomechanics in a little bit, but they have DESS Smart Systems, as I said, they have the digital components, and they also have analog components and everything in between. So your opportunity for lab analogs, as you see here, is certainly available. My apologies, there you go. So, and then you have also the scan flags, as we shared, with the tie-based scan flag, as well as there's an assortment of different kind of processes, and whether it's the select grip or whether it's the RM base or even the multi-units, which I'll get into now. And they also have what's considered a pre-milled blank, which is the interface. And now I know that for any of you people out there that are using VHF, I know it's been validated, FDA validated for use with the VHF milling machines and the DESS blanks. So getting into multi-unit, so you have the opportunity of getting into the lab analogs, getting into scan flags, or getting into any of the components. And with multi-unit, if you're doing an all-on X, obviously it's the same prosthetic platform as all the multiple popular brands that are being used. They use the screw head cut, which will allow for more materials of the abutment, and it's fully shaped connection geometry. And you can have correction angulations of 17 and 30% degrees rather. They also offer, as you see here on the left side, multiple gingival heights, depending on where the implant is and how submucosa it is. And the tie base is in 2 different heights as well. There's a lot of good information, which I'll discuss about in the catalog, but it offers you multiple gingival heights. It offers you the yellow color as well, and the straight angulation of 17 or 30 degrees. Now imagine 30-degree angulation correction can really get you out of a lot of potential issues or challenges down the road. Now, an example of a full bridge of 5 implants, and this is something that I've personally faced with, where, as we're seeing the popularity, and I think it's debated somewhat, but nonetheless, it was something somewhat popular, and it may very well be, of where it's dental tourism, where folks go into different kind of countries or whatever have you, and get their implants. Now they come back here and they either have to add implants down the road, it could be 5-10 years down the road, or something fails and they need to replace it. And that's something that which we'll get into towards the end of the presentation, I use the catalog to really be able to, as a resource for that. Because again, you may get a bridge like this with 5 implants, where 2 to 3 different systems in that one same bridge. And how do you restore that? So now you have a solution, the DESS Smart Solutions, where the tie bases are nonetheless the same costs, and it gives you the resource to be able to identify what kind of platform it is. Now imagine going back to my quote example, where now if there was 3 different implant systems and the dentist sent it to you, now you have to make 3 different phone calls to understand what the components costs are before you're even quoting it. One of them you may not even recognize. One of them may not even be available here in the US. But now you have a solution that in order to be able to provide that in a great way. So it really offers a significant versatility, and something that really helps the dental laboratory to generate these prosthetic and grow that department and create greater revenue in a way. Now, here's an example about biomechanics. So as I shared with you earlier about where to angulate the screw holes and where to place them so that they don't compromise the overall prosthetic. Oftentimes what I see sometimes is that where the access hole is also coming out of is something that we need to be mindful of, not only for as far as aesthetics, but for biomechanics. So if you look at this example here, which is the 2 implant supported 4 units, this implant happens to be coming out right into the embrasure or into proximals. And realize that wherever there's any kind of failure is typically where it's multi planes. So because it's inherently weaker there, only because the material is lesser there rather than in the solid space. So although this doesn't affect the aesthetic ramification because it's lingual enough, and certainly it doesn't come out if we had it left here, but nonetheless, I went ahead and I moved or angled it perhaps about 4 degrees further into the lingual fossa, so that it doesn't, not only does it obviously doesn't compromise the aesthetics, but now I have a stronger structure in order to support where that access hole is. You don't want to leave that access hole, or worse yet, you don't want to introduce the access hole by angulating it in a place where it will compromise your prosthetic. So whether it's in angulation wise, it's where the implant was placed, which could compromise, as here we're seeing in this situation. So just moving it to a more solid area. Or sometimes, as I said, in laboratories, folks try to angulate it where their concern oftentimes is the aesthetics, but they may unintentionally introduce a weaker prosthetic by placing that access hole in a place where it may compromise the longevity of the prosthetic. So the angle access holes is really something to really bear in mind with biomechanics to make sure that it functions, that it's able to absorb the mastication forces, and obviously the entire system or the entire prosthetic is in a more solid and sound process, and making sure that it doesn't compromise the aesthetics. So all these things are certainly our ability and what we can do in the laboratory with our CAD software to create a stronger, a better, a further lifespan for that prosthetic, for that patient ultimately. So these are all things to kind of think about when you're doing that. Now, what's on everybody's mind? Obviously, as I said in the very beginning, this is a third-party component. It offers us the laboratory community a significant value, not only in dollars, but also in labor savings, as well as being able to create solutions that offer us. But it is a third party. It is not an OEM component. And certainly you may hear from, and oftentimes it's the sales force that tells the dentist, well, does this void my warranty, which I'll address at the end of the presentation, because it does not void the warranty. Well, it may void the warranty for that manufacturer. However, you have a more robust and stronger warranty. Do they really fit? Yes. It's all about geometry and it's all about machining, which I'll show you some examples of in a second. Is it the same quality screw? It's the same titanium, surgical titanium quality that all the OEMs use, so it doesn't change. And why are they less expensive? It's also because the patents have run out, and therefore they could be produced in in a different way. So is it the same material? Absolutely. And let's get into that and what I mean by that. So when it comes to implant components, obviously the CAD and what we spoke about the biomechanics is different, but when it comes to the actual components, it's all about geometry, right? It's all about the platforms and the interface and how everything fits. Now, the abutment connection is geometry and precision milling. Now, I was fortunate to visit and visit the DESS factory, but also I've visited multiple other implant manufacturers, and quite honestly, it appeared that they all have this same machinery and the same software in order to create the same type of components, and obviously under a different label. But at DESS in Spain, they have the same technology and the same production method as all the major implant brands. So it utilizes the same design programs, the same machines, and most connections methods are free from patents, as I said. And what I was floored at when I found out that even at Spain, DESS even manufactures for some of those implant companies that claim that their parts are even better. So now you're utilizing the same titanium as OEM. So it's the same material, it's the same design program, it's the same machines, it's the same things, even to the point that some of these manufacturers are manufacturing at their site or their factory. That to me tells that a lot of the pushback and the contention is something that is of a moot point, because it's all about geometry, and it really truly is. So they even have a step further where setting the tolerances. So they measure the number of original components. Their equipment and machinery actually sets where they have their tolerance to assure fit and compatibility all the time. So their machinery actually assesses every single time each component. The moment there's any kind of deviation, which doesn't happen, the production stops until it gets recalibrated. So every component that you get is gonna fit and is gonna feel and act the same way as it did when you ordered it a month ago or whatever have you. So it's a very consistent process all the way through, and their machinery does this. Now they even take it a step further where they randomize the quality assurance and the quality compliance, and they actually remove and have their technicians view them under microscope to really make sure that the optical inspection machines that there's no tolerance for any kind of deviation. So that way they assure the quality in a great way. And DESS measures all the components which are statistically relevant to sample test in a batch. So as you see here, these are some pictures and of their factory and what they were doing, where they're able to, within specifications, be able to assess and make sure to verify that the geometries nonetheless are exactly the same. Their machines, as I said, continuously monitor production outputs and give automatic warnings if something is out of, just a little bit off and perhaps is not the same quality that is assured. And each component is inspected visually under a microscope to assure. So you have multiple safe fails with the quality of the geometry. And again, it's the same software, the same machinery, and the same other components that are utilized in all the major systems. This is just utilized for the DESS Smart System. And again, it offers you, the laboratory community, the best of what you can achieve. Again, it's a third party and you want to be always transparent. And it's ultimately the dentist's call as to what it is that they want to use to restore the prosthetic. But you have the information to be able to have a conversation. Ultimately, it's their decision. Whatever it is that they want to choose is what you can oblige with and be able to offer them a superior prosthetic while making more money and revenue in a great way. Now, as far as
here's our next question on OEM. If you wouldn't mind answering for us. Go ahead, Dan.
Oh, sure. So thank you. So as far as regulatory aspects, the DESS entire manufacturing process is regulated under the EU medical because they are in Spain. It also follows the EU MDR strictest rules. And the process is ISO 9001 and so on and so forth. So they have the products that are CE certified and have certification from Canada and the FDA. So you can rest assured that all the checks kind of have gone through in order to make sure that you're getting the product that you can stand behind and feel really good about the restoration protocol for that patient in a great way.
So just to get the results for you, Dan, 100% of our attendees are interested in offering their dentist clients an alternative to OEM components. So that's pretty good.
Excellent. Excellent. Well, hopefully, as I said in the very beginning, hopefully this webinar and this hour that you're spending with me, and I can't be grateful enough, is going to give you an information to be able to have these conversations with the dentists and really be able to show them what they can benefit from, which ultimately is the benefit for the patient in a great way. So now, as far as the warranty, and you hear this often, and certainly your clinicians will hear it as well from the sales reps from implant companies, that it voids the warranty. And that may very well be true, but let's be frank. I mean, when, I might be aging myself, but, some of the implant manufacturers have offered lifetime warranties and they quickly backed it up to 5 years, 3 years. And now most implant manufacturers offer 1 year for their components as far as a warranty. DESS has an extended warranty, which is a lifetime on all DESS components. I mean, as far as I'm aware, most implant manufacturers don't have that opportunity. And if there's still a pushback, it replaces the warranty for implants if original manufacturer refuses to honor. So DESS will even step in and replace that warranty in a great way, so that you don't have to worry, your clinician doesn't have to worry, because DESS will stand behind you. And again, it's not just DESS. You also have the strength of Henry Schein and the confidence of Henry Schein, because it's a true collaborative partnership between DESS and Zahn, Henry Schein. So that's where the warranty really has a tremendous, value to it, because it's a lifetime warranty for DESS parts, and also a lifetime warranty being from a third party if the OEM manufacturer refuses to warranty the restoration. So that's incredibly powerful as a laboratory owner, knowing and resting assured that my restorations and my clinicians are going to be at ease because the warranty is available to them. Now, as I said earlier, the catalog is something that I'm really excited about, because it offers a tremendous resource for us as a laboratory community. It offers us a product list. And as I shared earlier, I come across this every now and then where there's dental tourism, where there's an implant that I'm unfamiliar with. And this is the first place that I go to because, again, DESS is a global company. So they have all the different platforms throughout the globe. So if there's something that I'm unfamiliar with, I'll take a look at this catalog and be able to identify what kind of implant interface it is so that I can restore it. And even this catalog walks you through the entire process. So on the left-hand side, you see the different types of product lists, and as well as the manufacturers or the OEMs. And if you go from left to right, you can see that this is the implant phase, and it gives you the impression taking. So again, you have an analog, you have a digital, and everything in between, to the laboratory phase. Even if you imagine, they offer even the castable UCLAs in these as well. So you can do it everything from digital, which is, certainly the way I practice is, mostly is digital. Although, as I said earlier, if a dentist is an analog or a conventional dentist with a PVS type of impression, I'll still accept that and I'll digitize it as soon as I pour the model. So I'm able to use digital components or analog components or whatever solution is required by you in order to create that success, as well as tools and materials all the way down to holders for the pre-manufactured abutment. Now, again, compatible platforms, you can see that, obviously this is blown up. And this is also available, which I'll share with you in the next slide, for free. For everybody, just by downloading the actual resource. And again, I refer to this rather often because it helps me identify solutions that I may not be thinking about. But when I look at this catalog, I look at the implant and then I go across to the laboratory phase to the tools. And all of a sudden I see a part there that may be the solution that I'm looking for, but I just didn't think of it. And it's like that aha moment. And I found that to be very, very, very helpful. And as you see down here, you even have a castable type of UCLA type of restorations all the way through the Orem base. So it offers a great versatility. Now, where do you find the catalog? Now, there are catalogs that are available from DESS from Zahn, I should say, that are in print. And certainly your rep kit will have that. I personally like to go to the digital because it gets updated often. So the way to go to the digital, you go to the Zahn website, you go under digital materials, and the DESS Dental Smart Solutions will offer you that catalog. But it also offers you in that same space, the libraries are available to design, the tie bases, the Orem bases, and so on and so forth in both 3Shape, exocad, and dental wings. Now with 3Shape, you can choose which library you want to, if you're doing hybrid abutments mainly, then you can certainly do this. If you're doing the multi-unit, which is probably these two are the larger of the libraries that you would find. And then if you're milling locally, meaning you're milling in your laboratory or in-house at a dentist, certainly the pre-mill blanks is a great solution to be able to mill custom abutments right there, either in the laboratory. And as I said, VHF has validated, or the FDA has validated a VHF system with these pre-milled blank libraries. So if that's what you choose to do in custom abutments, you certainly can. And then at the very bottom here in the 3Shape, this is where you have the download of 3Shape and the catalog, if you will, in a great way. So, the idea with the DESS Dental Smart Solutions is that it really, and that's why I took a liking to this company very much, because it was very smart, and therefore the name, because it really took a look at the laboratory space, the restorative space, and seeing where they can add value. And they've absolutely done that in a great way. And hopefully I was able to share some pearls as to where the values are and how you can attain it for your laboratory to A, make more money as a laboratory community, and B, grow that prosthetic, grow that implant supported prosthetic in a great way that will give you the confidence and the pride down the road. So it's a great opportunity, and just a matter of tapping into the technology. And certainly this is available through Zahn with DESS. And with that said, again, I want to just really thank everyone for your time. Hopefully I've added value to your day and certainly to your business. And if there are any questions, I'm more than happy to answer it.
Yes, Dan, we do have a couple of questions. And the first one is, what is the maximum angulation that you suggest to access the screw access holes?
Okay, so that's a great question, and thank you for asking that. Again, it depends a lot on the chimney height or the length of the chimney. I find that if there is any kind of significant length, so if you're doing a molar that has 10 millimeters of length, I find that the 9 degree seems to be the sweet spot. The moment you push it beyond that, that's where you start having challenges with accessing that hole, or accessing the screw rather. The moment you use other platforms like the Orem or the multi-unit, you can stretch that out more, 17 to 30 degrees, but that's not really angulating the access hole. That's just angulating it is angulating the access hole, but you're not doing it in the CAD, you're doing it through the component. So when you're doing the component, when you're doing it through the CAD software, obviously 3Shape allows you, I think, 20 or 25 degrees, but just be mindful of how tall that chimney or that access hole is. You don't want to go, and I find nine degrees to be the sweet spot. Again, the longer it is, the less you want to angulate it. The shorter it is, the more liberty you have, and just realize that you have to be able to engage that access hole in order to torque it down, both you and dentist in the chair, which obviously if the dentist can't do it in the chair, that becomes a lot more critical than if we can't do it in the laboratory, but it's something to keep in mind as you're restoring these type of cases.
Okay, we have another question, and that one is, how far can you cantilever past the most posterior implant?
Excellent. So that is a very, very, very good question. I'm happy somebody asked that, because it comes down to the principles of the AP spread, which is the anterior posterior spread. So you have to measure from the most anterior implant to the most posterior implant, and you can only cantilever up to half or 50% of that space. Because what ends up happening is, if you do it any longer, if the AP spread is greater than the 50%, what happens is, as the patient continues to masticate the forces, it's going to create a lever system and may actually extract the anterior implants, which is obviously a catastrophic result for everybody involved. So the AP spread is the most anterior to the most posterior implant, wherever the dentist placed it. You want to measure that distance and only go up to, and that would be the very limit of 50% of that length. Anything more than that will absolutely compromise not just the prosthetic, but it'll compromise the implants that are placed into the patient. So it's something to really adhere to, and try to stay as 50% or lower. I would even do 45%, depending on the situation. If the patient is an incredible bruxer and has a very strong musculature, oral musculature, and the mastication bites, you may want to tone that down a little bit more, or you want to be able to bring it in a little bit further. So it really depends on where the most posterior implant site is that was placed by the oral surgeon or the dentist.